So I'm going to go through this, and if you have the questions that you have at the end, and I'm sure you're going to have more when I'm done than you have now, but that's a good thing, then let me know and we'll go into it more. But so now here we are with storm surge. Storm surge really is a big threat here. I mean, we're talking about the rapid rise of water along the coastline that you're not used to seeing. The rate of rise in a storm surge is like a tsunami. We're used to talking about tsunamis, but storm surge somehow doesn't sound as bad. But it is like a tsunami. It's just caused by a hurricane. Hurricanes are usually the villain in storm surges, and this is how a hurricane looks. It rotates counterclockwise. So if you happen to be where it says spiral rain band down there, that means the wind is onshore. And in a storm that's a category 4, like Ian, at 150 miles an hour, 150-mile-an-hour winds perpendicular to a coastline is going to blow a hell of a lot of water onto the coastline. So if the hurricanes were further out, away from the west coast of Florida, it wouldn't matter. But when they're coming closer and closer and going over Florida now, it matters a lot. If you're on the north side of this eye, the wind is from the land out to the water. That's why Sarasota Bay actually drains out into the Gulf of Mexico if we're in the right position. That happened for us during Ian. We were lucky. We were on the right side of the storm. 30 miles different in path. The scenery you would be looking at today would be seriously altered. We were very fortunate that, and I'll show you why. But we have a thing called rapid intensification. It used to be rare, almost non-existent, where a hurricane would go from 100 miles an hour today to 150 tomorrow. But this is what's going on. Look at that chart. We're getting rapid intensification of hurricanes. Sometimes 4 hurricanes go through this rapid intensification cycle in one season. That means a 35 to, this one is based on a 50-mile-an-hour change in 24 hours. It used to take several days for that to happen. Now it can take less than 24 hours for that to happen. So when a hurricane goes from a category 1 to a category 5 in a day, it gives less time to react, less time to evacuate, less time to prepare. So our options are getting smaller and smaller, but I don't know if people really understand that that's what's really been happening. So a hurricane rotates counterclockwise, and this is what it looks like in a cross section. And the eye is clear, and the air is hot in the middle of an eye. That's why there's no clouds. But if you look at this picture, I'm showing why the storm surges. The ocean is in dark blue, and the light blue on top of it is the rising sea level because the pressure in the eye is less. So think about the Earth's pressure pressing down on you. And all of a sudden, in a severe hurricane, the pressure is a lot less. And that lets the water rise in a bubble inside the storm. And then you get the westerly winds blowing it onshore. That's why we get a storm surge in the first place. So that's this bubble right here. So this is the beach. And we have 3 things going on here. One, we're having increasingly strong hurricanes. Number 2, we have higher sea levels. We just talked about that. Number 3, we have all of us who want to live there. So the damage is going up exponentially for those 3 reasons, and they're all related. If nobody lived there, it wouldn't matter much. But everybody wants to live there. And then everybody has to leave in a hurry. And we have to have a way to save lives and protect people and to limit property damage. This is the NOAA models that look at storm surge. In the blue, the yellow, and the red, those are areas that get 1, 3, and 9 feet of storm surge that in those low-lying areas. And look at where they, and look where they are. You see that right there? That is where Fort Myers Beach is. And you see that right there? And all up in here. You notice you don't see it much on the east coast of Florida. It's here on the west coast, where we have a higher threat for storm surges here than they have on the east coast, because the continental shelf here is so shallow. On the east coast, it drops off very fast, and it makes a difference. Since 2017, we've had 6 Category 4 or 5 hurricanes. These hurricanes have done a total of $450 billion in damage, and they've killed hundreds of people. So this is not normal. Before 2005 Category 4 or 5 hurricanes, it took decades to have that many. And now we had this in 5 years. So Ian was so far as 114 billion. Ida, which was last year, was 81 billion and drowned 50 people in New York City. 1,700 miles from where it hit, or 1,200 miles from where it hit. Laura was 20 billion. Michael, which was the only Category 5 and it hit Mexico Beach, was 30 billion. Irma, which we all remember here, was 93 billion. And Harvey, because it's Texas, was 151. They always do things bigger in Texas. So here's the Florida map. And what I say is, this is a takeaway, okay? Know your elevation. It could mean your life. The people in Fort Myers did not know their elevation, because if they heard what was warned, they would realize that what was coming was going to drown them. But they didn't know their elevation and said, well, I'll be fine. I've always been fine. I'll be fine this time too. So local factors impact storm surge. For instance, the shallow continental shelf means higher surges, but on the East Coast, they'll have bigger waves. We have smaller waves and higher surges. On the East Coast, they have smaller surges and higher waves. So when Nicole hit Florida on the East Coast after we had Ian on the West Coast, it was only 75 miles an hour. It did unbelievable damage along the coast due to high waves. So higher onshore winds, storms moving perpendicular to the coast, where the winds come in perpendicular to the coast, slower moving, larger storms, all have impact on storm surges. This is the track of Ian. Ian was an unbelievable storm, and I'm going to tell you why. You can see how close it got to us. And the red is where it went to Category 4, just basically right off the coast. It started intensifying south of Havana. It went through a rapid intensification cycle south of Havana just before it hit Cuba and ruined their entire tobacco crop. All of it was gone. When it got into the Gulf of Mexico, it went right into the slot that we said in 2021. If a storm gets into this slot, we're in trouble here in Florida. And it went right in there. And within 18 hours, it went through another rapid intensification cycle. It's the only time in 50 years of me being a scientist I've ever seen this happen. This is the only time. So this is what it looked like coming in on the Weather Channel. The storm surge coming right into Fort Myers and Charlotte Harbor. And this is the forecast by the National Weather Service storm prediction storm surge model. And it shows 12 to 18 feet of storm surge. And guess what? That's exactly what they got. This was well forecast with more than 24 hours in advance, and it doesn't take 24 hours to get in your car and leave. But some people didn't. Okay, let's look at this. And if you could stop that at 2 minutes. There's the eye forming. That's lightning. And that's when it goes over Cuba as a Category 2 storm. Now watch the side. Look what happens. It wobbles. And a new eye forms, a big one. And this is what it looks like after. There were houses in here. Okay, now I'm going to show you something that's going to shock you. And it's the storm surge coming in. Just go back 1, 2. Whoop. There we go. Ian storm surge. No, you got to go up and click the, okay, good. This is Fort Myers Beach. Notice these palm trees. Notice this house. side when the eye went by, blowing all the water out to sea. So, if that doesn't take the wind out of your sails, I don't know what will. So this is a very unique picture. It's an infrared, a multispectral image of Ian after it went over Cuba, and it started a second rapid intensification cycle. This is the old eye. It was 12 miles wide, and this was the new one forming. A few hours later, it was like that. And so a 12-mile eye became 35 miles wide, and it intersected the coast. People said, well, it moved northeast. It changed course. It didn't. It was on the same course, but the eye got bigger and it expanded onto the coastline. And the winds went from 120 to 150 just before it hit. So this is like the worst case scenario you could imagine, but it happened. Thank God it didn't happen here. This is probably one of the most spectacular pictures I've ever seen. This is the eye looking down into it. That's the ocean, or the Gulf of Mexico. And this is the big eye just coming on shore. And here overlaid is the coastline, Fort Myers Beach, Sanibel, etc. All right. This is another interesting picture. This red area where the hurricane went through rapid intensification the first time is in the red, 3 degrees centigrade warmer than normal. And then it got right here over another area of 3 degrees centigrade warmer than normal and had a second rapid intensification. Water is rocket fuel for hurricanes when it's hot. And it went through 2 intensity increases in 2 days like that. And that's what you get when you get a warming climate. That is one of the impacts. This is the area of hurricane force winds. I never want to hear anybody tell me that the Princess is protecting Sarasota again. I mean it. And some people still think we missed it. Yes, go ahead.
What was the actual temperature of the Gulf that, after it went past Cuba?
88 degrees.
88?
88 to 90 degrees. Let's see here. So this is what Fort Myers Beach looked like 4 hours after it came ashore. And I want you to look at this building. Okay, these are all, there's nothing left. I mean, there's not even debris. This is that building, the other side, to give you a perspective. And look at this in here. And you see these waterways? Man-made waterways? Beautiful design, right? It amplified the storm surge because the storm surge had a chance to go right up those waterways, all the way inland. You know how far it went? 15 miles. 15 miles. This is the other side. All the way on the other side. Look at this. So the winds were 155 miles an hour. Category 5 is 157. It was 10 miles an hour it was moving. The average hurricane used to move 20. It was 10. The size was twice as big as Charlie in 2004. That went over the same spot. The storm surge was 15 feet high. We had 24 inches of rain and at least a 200-year inland flood 2 years later from all that rain. And we're going to talk a little bit about that pretty soon. So this is the toll to date. 5,000 homes in Florida totally destroyed, 35,000 badly damaged, 350,000 cars were wrecked, 7,000 boats were destroyed, 160 people died, 80 of them drowned, 80 drowned because they didn't know what a 12 to 15-foot storm surge was, and they lived 4 feet above sea level. Know your elevation. It could save your life. Most of these people who drowned, by the way, were not poor. They lived in houses along the shore. A lot of them were $1 million houses, and they thought they were safe. Every single place in Florida had gale force winds, and the dark red is where they were super hurricane force. This is Hurricane Nicole, the latest storm ever to hit the east coast of Florida. It hit in November. It was only 75 miles an hour, and the eye looked nothing. It's very ragged, but it did a lot of damage because of the huge waves that it whipped up. And it was a huge storm, and this is how it traveled across Florida. We got some effect here, but compared to Ian, it was like a walk through the tulips. This is what the hurricane surge model forecast all along the coast, all the way up the East Coast. Even with a minimal hurricane, there were 3 to 5 feet of storm surge. And even here, we had a little bit, but north, more. That's the hurricane force winds. Compared to Ian, not very much. But the whole state of Florida had gale force winds again because these storms are really big. And this is the area in red, like I say, that has 9 feet of storm surge potential. This is what a Category 2 would do to Southwest Florida if it hit us perfectly at high tide at the right angle. And I'm going to show you, this is a Category 2 storm, and this is why we need to be ready. All of this is what we're used to see the concave coastline. That's really bad for storm surge. But notice up in Tampa, there's quite a bit. It doesn't look like we have a lot here, but wait. As we blow this up, a Category 2 storm, perfectly aligned with the coast, would inundate the entire Keys, the entire Barrier Islands, downtown Sarasota. This will change because some of this roadway has now been raised. Not all of it, but some of it. But this is talking about greater than 9 feet above the ground of water. We could have that in a Category 2. This is not a super hurricane. This is just a hurricane that hits at a perfect angle. That's Tampa Bay. So that's it. So now let's have some questions about storm surge. Yes.
I just wanted to ask Bob, you said about some of the roadways have been raised already. What about the new roadways that have been off the Ringling Causeway and the new roundabouts in that area?
Yes, so we have good news and bad news. The good news is where the construction was, they raised significantly, and that is a fabulous thing.
Yeah.
But where the project starts from, right in front of the Ritz-Carlton Hotel entrance on, as you approach the bridge, that's a very low-lying area there, and you just have to walk down there and see. It's 2 feet above sea level. They did not raise that part. And as far as I know, there are no plans to raise it. I've been raising it as an issue because I know what could happen, and we saw what could happen, and there is no need to have a catastrophic loss of life because 200 or 300 feet of road has not been raised. This traffic circle is an example. We have examples like that all over Florida. And that's why we have to work together differently and design differently than we did in the 1990s, because we're using old processes to plan like nothing's happened, and it has happened. Any other questions? Doc?
Well, let's say the last 30 years, Americans on balance have been moving to the Sun Belt. Between the issues you raised of climate warming and now storm surge, it seems that at some point that's going to have to reverse itself because it's going to become inhabitable.
Well, again, this is like, I feel like we're in that choice area on what can happen. Yes, we're going to have an overshoot of temperatures, but if we do the right things, we think the temperature will adjust down and the rate of change in temperature rise will come down. That gives us a bridge to the future, if you will. We have to adapt first so that we can mitigate, but we can't mitigate and lower our carbon footprint to zero unless we have a bridge to get there. And that's what adaptation is all about. And that's what we can control if we want to. $1 spent preventing is probably worth $20 of destruction that could have happened. If we had places for 350,000 cars to go with a 2-day warning like this storm had, or at least 2 days, and those cars were moved off, we wouldn't have lost 350,000 cars. That was a choice not to do anything. There was nowhere for them to go. But we could plan so there was a place to go. We could plan so every citizen that lives on the coastline has a pre-assigned place to go. We have parking apps that we can reserve a parking space in St. Petersburg for 5 o'clock tonight. But we don't have an app that says we can reserve a place to evacuate to that's not 500 miles away, or where we bring our cars. We could do that right now. We have the technology to do that. Yes.
Yep. My question is, are breakwaters practical to limit the impact of storm surge? Obviously, we can't stop the storm surge, but can we mitigate or adapt down the consequences? Is that practical or just impractical?
I think it is practical, but it's hard because we've forgotten about all of that while we were all moving down here. And, you know, I get it. I lived on the beach too. I lived in North Longboat Key. Where's Al? He knows. He and I worked on together the project on the north end of Longboat Key because that part of the key was literally washing away. And last December, a $10 million project was finished that had under the sand groins on it. And it saves, this year, the sand loss is down 70%. It'll pay for itself in 3 years in lost sand. It's good engineering design. It's what we can do. It has been done. It's an example of what we can do when we decide. There's no reason we can't do that kind of thing, but Florida, I believe, spends $2 billion a year throwing sand on the beach, and 2 days later they have to throw more sand on the beach.
Over here.
Let's see.
Bob, we have one over here that's ready.
I'm sorry?
Sorry, I have a mic
Oh,
ready over
I'm
here.
sorry.
Yeah.
Thank you.
Yep.
First of all, thank you so much, Bob, for that informative and yet terrifying presentation. think we're all a little bit more awake now. My question, I have two questions. First of all, you showed us the photos from Fort Myers Beach and all down the south. Thousands of people right now are having discussions with their insurance companies in their own internal families whether they should rebuild. So is the answer to rebuild in some of those areas? Is the answer to build higher? And then secondly, obviously we're all rather familiar with hurricanes and with these issues, but you talked about this being an issue that can only be solved through our political votes. Fine for us, but how do we get people in Kansas, Missouri, Utah, Colorado, people who are unaffected by these very specific issues and maybe don't see this as important an issue as it is? How do we get them to pay attention and to care?
Well, two good questions. And the answer is, I can't really tell you a black and white answer. What I can say is that we have structures that were built to Category 5 standards on Mexico Beach and on Fort Myers Beach that did not wash away, and they're fine. The building codes, and I'm going to talk about this a little later, were designed in the 1990s for a 1990 type climate. The last time we really had a big building code change was after Andrew in 1992. The climate has changed, but the building codes has not. We've got to get the building codes up to what it needs to be for 2050, not for 1990. Houses last more than 30 years. If you build them now, they should be designed for 2050, not for 1990. So that's a big part of the answer. The second part is, we have the absolute ideal situation in Florida. Everybody in every state wants to be here in the winter, and they all own houses here. They do care, but somebody has to tell them. They don't know. They leave, they lock and leave, and then they come back after hurricane season. The house is there, they're fine. But it's different now, and it's about education. We have to educate the public. Climate scientists don't usually do that. They're out there doing their science, and they're happy as a pig in you know what. But we need more people walking across the boundaries to interact with the other sectors so we can inform the decisions and get those things done now while we have choices we can make. That's the best I can answer. Yes, sir.
Bob, I think trying to get people away from the coast is going to be a more manageable problem than climate change, because it's their hope and their dream and everything they ever wanted. Recently, the United States government has shot off a rocket that altered the course of a meteor. What, if anything, could be or is being done to try to alter the course of hurricanes, or to be able to dissipate the hurricane itself?
Well, I have a personal story to tell on that. Back in the day, I used to fly into hurricane. And during that time, NOAA was seeding hurricanes with silver iodide to disperse the wind force. But what happened was it did do that, and then 24 hours later, it would grow back bigger. So we quit doing that. So what I'm saying is, we can't run real-time experiments on humanity hoping that it's going to work. What we need to do is be accountable right now and do it ourselves. What we can do. We can't change the atmosphere and put solar shades. I mean, if we do those things, that's desperation. Could they work? Maybe. But I'm not for real-time experiments on humanity. I just want us to make it. And I think there are ways to make it without doing that kind of stuff. But it's always easier to say, well, let them do it. There is no them, guys. There's only us. That's the bottom line. One more question. I don't know, whoever should get the mic to, I can't decide.
Education, I mean, you said it, it's not just having the information out there, but actually getting through to people, getting the message so it has an impact. And I'm shocked by the story of the traffic circle. Why it wasn't raised when it's 2 feet above. And so I'm wondering, is there a story there? Was there discussion? Was there somebody out there saying, you better raise it? Why, how could that happen?
Because the state of Florida and the county of Sarasota and the city of Sarasota operate in their yard line. And the state is largely in charge of roads. The local people have some input into it, but it can be taken or not taken. There were 2 public hearings, and there were 6 comments about the flooding there. And the answer was always the same: it's not in this project. And it will be addressed in the future, but no date. But that was before Ian.
So getting the message through is all about more disasters.
Well, it can be, but I hope that's what, we have carbon too much out here, and we have a lot in here, but we got to engage this one. Limit this one and use this one. And it's common sense when you know what's going on. So I don't know. I hope the CAC is a bridge to those kinds of issues. They're important and they're local, and that's where we experience climate change. We don't experience it in Bangladesh. We care, but we really care about this. And this is what we have to work on. And this is what we have.